So KEQ, every time we write the KEQ, what do we have to put beside it? At the temperature, a specific temperature, all right? Because the only thing that changes the KEQ is temperature. You need to remember this. It's the only thing that will change the value of the KEQ. That's why we write the KEQ is 100 at 22 degrees or whatever temperature we're talking about. If there's a change in pressure or concentration, all right, the equilibrium will shift, but the KEQ stays the same because it's the ratio of the concentration of the products and stuff. All right. The actual value of the KEQ does not change, even though there's a shift. So we can look at this. So if we have 2 moles of nitrogen dioxide plus energy, so it's an endothermic reaction, goes to N2O4. The KEQ is 1 at 20 degrees. And so we're at equilibrium. We have 4 moles of N2O4 and 2 moles of NO2. If we increase the temperature to 40 degrees, okay, what's going to happen to the equilibrium here in this reaction? It'll shift right? We jack up the temperature, so the equilibrium shifts right. So the N2O4 will increase, and it increases to 4.5 molar, it's shifting right, which means the NO2 decreases, and it goes from 2 to 1. Right, that makes sense. If we increase this by half a mole, whatever you want to call it, right, we need 2 moles of this to do that, right? Does that make sense? Okay, so this goes down by 1 mole, this goes up by 0.5 moles. If you measure the KEQ now, so the KEQ expression is going to be concentration of N2O4 divided by the concentration of NO2 squared. (4.5 squared divided by 1.0, because those are the new concentrations. Oh, I wrote the squared on the wrong one. Divided by 1.0 gives me 4.5. The KEQ changed. All right, we went from 1 to 4.5. That's why we write the temperature every time, because then what you would say is for this reaction at 40 degrees, the KEQ is actually 4.5, not 1. Okay? Does that make sense? What if you change the pressure? So we're going to decrease the pressure by doubling the volume. So we increase the volume, which means the pressure goes down. Okay? Which way will this equilibrium go if we decrease the pressure, i.e. increase the volume? It goes to the left because it wants to go to the side with more gas molecules. Entropy, right? So we shift to the left. This means NO2 should increase. N2O4 will decrease. What happens to the concentrations when you increase the volume? And we doubled the volume. So what happens to the concentrations? They get decreased. If you double the volume, they're going to decrease by half, actually. But yes, they decrease. Okay. So what happens is the NO2, as soon as you increase the volume, the concentration of NO2 gets cut to 1.0 because we were at 2. All right. And then there's an initial decrease in the concentration of N2O4 to 2. Then the equilibrium shifts. Okay. So it shifts to the left. The NO2 goes from 1 molar up to 1.35, and the N2O4 decreases from 2 to 1.8. Okay. 2 minus 1.82. I can't do the math. 0.18. That's it. Okay. All right. So if we measure the KEQ now, once we've done this shift, the equilibrium change, it's the concentration of N2O4 over the concentration of NO2 squared. N2O4 is 1.82. N2O4 is 1.35, but it's squared. If you do that, you're going to get 0.998, which is actually 1. And the KEQ is the same. Okay? So if you change the concentration, so you jack one of the concentrations up and it shifts left or right, KEQ stays the same. If you change the volume or the pressure, KEQ stays the same. If you change the temperature, KEQ changes. It's the only thing that will change the KEQ. Okay? That's a classic test question. I can say, what happens to the KEQ and give you a series of things, or I can say the KEQ for the reaction and then say, okay, you change the temperature, what's the new KEQ? And you would say, reverse that. You change the concentrate, or you change the volume. What's the new KEQ? Same, all right, even though it shifts. The only thing that changes is the temperature. Okay. That's just the graphs of it, but you can see when you increase the temperature, they go up, they go down. We get a new ratio here. In this one, the concentration changes the same. The ratio essentially stays the same. All right. That's it. All you need to remember from this lesson is temperature is the only thing that changes KEQ. Equilibrium's now over, peoples. I know. Except KEQ kind of follows throughout the whole course. We just call it different things. Next unit, we're going to call it KSP. You'll see why. Okay, answer those questions, and then I posted all the reviews in the classroom. Do you want me to print off a review? I'll print one review. We'll take a vote on which review. Or no, okay.